Okay, so our quick warm-up today, hopefully finished up here. What happens to the graph of x squared when we add 5 to the end? Good, it shifts it up 5 units, translates 5 units up. How about the graph of x squared when we have the x minus 1? Go 1 unit to the right. Okay? When we add 2? Good, left 2. And then the last one there, we go to the right 5 and up 3. Okay. Any questions? All right, should have out Friday's assignment, please. Okay, so ladies and gentlemen, you were asked, we actually finished number 1 as a class. We talked about vertex form, or a form in which we could see our shifts with our a on the outside. We have x minus h on the inside and plus k. The area we didn't talk about was the horizontal shrinks or stretches, would be the extra term on the inside here, kind of like a b term. All right, but I'm not too terribly concerned about that. It does come into play a little on number 4, but you could actually get rid of that by multiplying it out. So let's take a look. There's number 1 and number 2. Number 1 takes our parent function here, x to the 5th, and it shifts it 1 unit to the left. So I'm taking this middle point 1 unit to the left and up 2. Yes, Mackenzie? Then write them down. Yeah, this is more of a notes thing for you right now. Number 3 takes our parent function, x to the 6th. Notice I changed my scale on the y-axis. It reflects it, that's the negative. It stretches it by a vertical stretch of 5 there, and then it shifts it to the right 2 units. Okay? Yeah, you could write it in a different order. Remember, the vertical doesn't affect the horizontal. Okay? Sure. Yep. Number 4, we take it. Now, I know some people that I've talked to actually cubed the 1/2 to make it 1/8, which is okay. But then it goes from a horizontal stretch of 2, which is what's there. If you cubed it first, then it's a vertical shrink of 1/8 if you cubed it first. So I would prefer, like if you want to graph it that way, that's fine. But since they wrote it like this, I prefer you say it's a horizontal stretch of 2 based on that writing, and then a translation 4 units down. Remember, if something's stretching horizontally, it's pulling away from the x or the y-axis. Okay, so what was 1 unit away is now twice that amount away. It's 2 units away. All right, number 6. Number 6, taking x to the 4th. It's a vertical shrink of 1/8 and then a reflection in the y-axis. Once again, when you actually graph this, that's like having a -1 hanging out in there. And when you raise that to the 4th power, it just disappears. That's why the graph doesn't look any different in terms of it being reflected. Okay. However, technically this point moved over there, okay, when it reflected. Number 6, it's x to the 5th. You take that, you move it 10 units to the right. Notice I changed my scale here. I went up by 2s. 10 units to the right, and then added 1. I also changed my scale on the y-axis, which you really didn't have to do. But. All right, questions on 1 through 6 there. Last one is number 7. I'll make those available. Okay, so they'll be in the answer book stuff. Number 7, graph this. So you have your function f of x right here. You're going to take it and move it 3 units to the right, and then you are going to reflect it over the x-axis. So this slides over and then reflect. Questions? Yes, Kendall? Well, we're going to work on some of the backside today. Yeah. So you are ahead of the game. That wasn't the question that you were, or the answer you were probably looking for. Sorry. To see where we're at on this, I want you to try problems 3 through 5 here. Okay, actually, not number 5, 3 and 4. Let me cross out 5 here. Just because we didn't do that one, so that wouldn't make any sense to you. 3 and 4. Hey, can I have your attention up here, please? Wrap up discussion. Okay, so if this is f of x, and we want the opposite of f of x, okay, write a rule for g, then graph each function, describe the graph. I'm going to talk about the rule more than I am the graph right now. We've talked a lot about the graphs. But in terms of the rule, just so that quick review of this notation, we're taking what f of x is and then multiplying it by -1. So if f of x is this, and I am taking the opposite of that, that's what g of x equals. Okay, so really I should distribute that in. So g of x equals -x to the 5th plus 4x minus 6. That's what g of x is. Okay? If we describe the transformation, it's just what's happening with this. What's that tell us it's doing? Yeah, it's flipping it over the x-axis. Okay, your y values are changing. So if you think back, like if you're ever confused, remember if it happens on the outside of the parentheses, then the y values are changing. Which means if I was here and I want to know which way I'm flipping, am I flipping this way or down? Well, when I flip down, the y's change. When I flip left or right, the x's are changing. Right? Okay? So you want your y's to change because it's a negative. It's on the outside of those parentheses. All right. Okay, so there's the description in the function. Like I said, I'm not going to worry about the graph right now. But number 4, let the graph of g be a horizontal stretch of 2, followed by a translation 3 units to the right of the graph of f of x. Write a rule for g. So g of x is saying it's a horizontal stretch of 2, followed by a translation of 3 to the right. So if you remember earlier in the year when we talked about this, we started doing these as separate pieces. When it's doing a horizontal stretch and then it's moving it to the right, that's also a horizontal thing. Okay, so one is going to affect the other depending upon the order in which you do it. So do it in 2 different steps. So take and rather than calling it g of x, since we're going to do 2 steps, I'm going to say h of x is going to be equal to stretching it by a factor of 2. Now when I stretch f of x by a factor of 2, I'm actually taking f of 1/2 x. Okay, remember, when it's horizontal, it's kind of counterintuitive. It's opposite in there. Okay, so it's f of 1/2 x. So that means I am plugging this in for what value? For x. Okay, so I end up with 8 times 1/2 x plus 3, which is 4x plus 3. That's h of x. Okay, there's my horizontal. Did I forget a cube? Oh, I did forget a cube. Thank you. All right. Well, that makes it a lot different there. Sorry. So that's 1/8, which makes that just x plus 3. Is that better? All right. Thank you for pointing that out. Okay? Yeah, so you have to move. Oh, yes. Man, twice in a row there. Good? And so from that point, we're going to take h of x. We're going to call it now g of x because it's our last step. What are we doing to it? We're translating it 3 to the right. So how do we show that? Good. Just subtract 3 inside there. So if h of x minus 3. So this piece gets plugged in for that x right there. And I won't forget the cube this time. Okay. So that is now x minus 3 cubed plus 3. There's g of x. Okay. So that means my graph is, I've done my horizontal stretch of 2, and then I've shifted it 3 units to the right. All right. This was the part where we struggled a lot earlier this year. Okay. Go 2 different steps, please. It'll help you out. All right. Questions? Kendall?
So, like, where did the 8 and the 1/2 go?
The 8 and the 1/2. When so if I kind of highlight this piece right here and step it out, that is 1/2 to the 3rd power is 1/8. And then you have times 8. So 1/8 times 8 is 1. Good question. Matt?
So one on a graph, wouldn't that be, because if you look on a graph, if you have a horizontal stretch by a factor of 2, then it should be shrinking in height by 1/2, but then you're shrinking in height instead by 1/8. Like if you were to look at it graphically.
Right. Well, when I distribute that 3 in, it becomes a vertical stretch. So this is a horizontal shrink of 2, or excuse me, horizontal stretch of 2. But as soon as you cube it, you've now brought the x cubed in here. So technically it's not in parentheses. It's not inside like that anymore because the cube's now attached to the x. The only reason I left the parentheses there was to show that became that. So really you have 1/8 times 8, so 1x cubed. So this if you just looked at it like this would actually be a vertical stretch or a vertical shrink or compression of 1/8 once you bring that cube down. Okay? Yeah.
Unrelated question. On these, when you're graphing, would you just have to find the zeros?
Yeah, find the zeros and then maybe a point on either side. Oh, yeah. Okay. Look at your student journal again, real quick. Almost done here. Okay. All right. What I want to do right now, first I want to just deal with the notation. I'm thinking that once you have the function down, you can graph it. Am I good on assuming that? Like the graphs you did last night, they were okay. I didn't get a lot of questions about them, so how many of you are good with the graphs? Okay, if you need help with the graphs once you have the functions, then talk to me. Okay, I'm going to leave it at that. I'm not going to go through tons of graphing, but I want to talk about the notation because the notation is fairly new. Okay, so if I'm taking number 8 and 9, and I am writing I have kind of what's happening here, but I want to actually find what g of x equals so I can graph it. I know that what I'm going to do is I'm going to do a horizontal, right? This is going to reflect over which axis? The y-axis, and then I am going to shift it 9 units down. Okay, that's what that means, but the function I actually want to graph is based on f of x. So I am taking f of negative x, so rather than starting with g of x, I'm going to deal with this first. Okay, and maybe I'll do it in 2 steps. They're kind of independent of each other, so it's not as big of a deal here. But you're taking the opposite of f of x, or I'm sorry, you're doing f of negative x, so you're plugging negative x in for x. If you think about it in the 2 steps that we did. So you could call that h of x, say, okay, well I'm going to plug this first piece in, that's going to give me negative x, okay, to the 3rd, plus 8. negative x to the third. Negative times negative times negative is negative. So it's still negative x cubed plus 8. All right. And then to get to the g of x, I'm taking h of x, and I am subtracting 9 from it. So really, I'm taking this whole thing and subtracting 9. So it really becomes negative x cubed minus 1. Negative x cubed minus 1. So there's the function you would actually graph. Okay? Tell your neighbor what you have to do to number 9 to get to g of x. Okay? Tell them the new function once you got it. So we're just multiplying everything by 5, right? Okay, so 10x to the 5th minus 5x cubed, that's a 5, x cubed plus 5. Very good? Okay? Any questions? Okay, I want you to take a look at 10 and 11. Okay, start with 10. Do your best on it. All right, let's see how we did here. Okay, so we're taking it and doing a translation 1 unit left, followed by a reflection in the x-axis. So if I'm going to the left and then I'm reflecting an x, this one right here affects horizontal. This one affects vertical. Okay, and then a vertical stretch, which also affects vertical. Okay, so these last two are going, you kind of have to worry a little more about. So if I'm dealing with f of x, and I want to take them in order here, translation 1 unit left, we'll call that h of x equals f of x plus 1. That's the 1 unit left. Okay, so this piece goes in for x. It goes there and there. So substitute there and there. So that's going to give me x plus 1 cubed minus 6 times x plus 1 squared, all plus 5. All right? So from there, if I'm cubing this, anyone cube that? No? No one cubed? Everyone left it? You think you cubed it? X cubed plus 3x squared plus 3x plus 1. Okay? Minus this right here. This is, remember, x plus, or x squared plus 2x plus 1 times 6. So that's negative 6x squared minus 12x minus 6. And then all plus 5. Simplified, we have an x cubed. We have 3x squared and negative 6x squared, so negative 3x squared. We have 3x and negative 12x. So negative 9x and 1 and negative 6 and 5, I believe, is 0. So h of x equals all that. Do I have a second? That good? Okay. Followed by reflection in the x-axis. Reflection in the x-axis. Huh? I can't hear you. Yeah, so it would be f of, or yes, in this case it would be h of negative x, right? Is that right? How many say yep? That's good? Nope. Hey guys, I don't want you guessing. So if I'm just sitting up here doing this, I want you thinking through it. If I'm reflecting an x, which am I changing? Vertical or horizontal? Vertical, which is changing x or y values. Y values, which means it happens inside or outside? Should happen outside. Thank you for catching that right away, Sylvia. I was trying to get people to think through it. Okay, negative h of x. All right, so that means I'm just flipping all these signs, correct? So I guess we'll call that I of x. That's going to give me negative x cubed plus 3x squared plus 9x. All right, we've now taken care of the reflection in the x-axis. Now we're doing a vertical stretch by a factor of 2. Is that happening inside or outside? Vertical. Vertical happens on the outside. So we're doing 2 times I of x. Thank you. 2 times I of x, which means I double each of those things, which means I get negative 2x cubed plus 6x squared plus 18x. That is actually my g of x. Sure. Yeah, I probably should use a different value than I. Maybe like m or something. Yeah, otherwise you might think it's like negative, the root of negative 1. That's right. Okay. Ladies and gentlemen, there's one last problem. How many are getting better at these? That's the plan. All right, try number 11. I'm going to be walking around. As I'm walking around, please ask for help if you need it. Do your best on it. All right, so horizontal shrink by a factor of 1/3. So I'd have, if I did h of x again, it would be h of, or h of x equals f of what? 3x. Okay? And that 3x gets plugged in for each of these x values right here. So it's going to get plugged in 3 different times there. So we're going to have 3 times 3x to the 4th plus 3x to the 3rd plus 3 times 3x to the 2nd plus 12. That seriously is a lot of 3's. I mean, legitimately, especially when you have to raise it to the 4th power. Because then you have 3 to the 4th, which technically is like 3 to the 5th. But 3 to the 4th is 81 times 3, or 243. X to the 4th. You got to distribute it to both, right? So 3 to the 3rd Okay, how many got that part right? Questions on that part? Now I need to take and move that 8 units down. So if this is h of x, if we use like k of x is going to go 8 units down. We're going to take h of x and move it down 8, which means we're on the outside. We got to subtract 8. So really, the only thing that's changing is the 12. It's becoming 4. So it's all the same stuff. It's just that becomes 12 minus 8, or 4. 243x to the 4th plus 27x cubed plus 27x squared plus 4. That's k of x. All right? Okay. Reflection in the y-axis. Happen on the inside or outside? Inside. Y-axis, if we're moving over the y, you went from here to here. That means you're changing on the horizontal, so it happens on the inside. So that means we need to take k of x. I'm running out of room here, so I'll write it on here. Okay, so g of x now, our last piece, is going to equal k of negative x. That means negative is being plugged into each of those x values. And we've worked on this now. You should know that if it's even, is it affecting it? No. So that's going to be 243x to the 4 still. But if it's odd, just changes that sign. So it's very similar to that one. It's just one sign difference in that one. So we only add one odd power. How many got it? Right, man. It's good news. Woohoo!